All right. So last class, we talked all about calculating molar mass. We also talked about what a mole is. But we talked about with molar mass, kind of the basic setup is you first list the elements that there are in the molecule, list how many there are of each, look up their atomic masses on the periodic table, multiply them, and then add them together. That's what we focused on yesterday, and it was pretty cool. Okay. Today, what we're going to be doing is we are going to be using that information to calculate going between either moles and grams. All right. That's the kind of thing that we're going for. So if I say, hey, there are 4 grams of oxygen that's going to combine with 2 grams of hydrogen, you can't really estimate how much water would be made, unfortunately. You have to go to moles, okay? So the trick with this entire thing is going to moles. But the first example that I'm going to use is actually moles to grams, okay? So let's check this out. So I have here, what is the mass of 2.5 moles of water? Okay, what is the mass of 2.5 moles of water? Well, we're going to be doing the same basic dimensional analysis that we've been doing this whole time. All right, write down what you have and what you want. 2.5 moles of water equal blank grams of water. Okay, cool. Bam, did it. Step 2, create the grid, put what I have right here and what I want over here. Bam, did it. We're all on the same page, right? Now it's time to use the molar mass in step 4 right here in the middle, okay? So in order for this to work, as you know, whatever unit is in this top left has to come down here, okay? And whatever, and this is a one step, whatever is here has to go here. Okay, cool. Bam. So now I'm ready to stick in some numbers, okay? If the question is, can we just write H2O, can we just write moles? No, you actually have to write moles of H2O, okay? It's a lot, but you'll make sense come Monday. So here we are, and we're ready to stick in some numbers. But what numbers do we stick in? Well, this right here is where the side hustle comes in. This is the practice that we did yesterday, okay? This right here, we did it in our example problem up above, 2 times 1.08. This right here is our molar mass of water. It is 18.015 grams per mole, So that means 18.02 grams goes on top and the 1 mole goes on the bottom. Now the last step's pretty easy. I just multiply everything on top, 2.5 times 18.02, and I get 45.5 grams of water. Okay? Okay. Let's go ahead and do the opposite of that real quick. Let's go from grams to moles. Okay, how many moles is 45 grams of hydrogen gas? Write down what you want, what you know. 45 grams of hydrogen gas is equal to blank moles of hydrogen gas. Yes, you should write that hydrogen gas, and yes, you should recognize that it's H2 and not H. Next thing I know, create a grid, put what I want, what I have up here, what I want over here. Same as before. Next thing, bring down the units. This unit comes over here. This unit comes over here. Okay? Cool. Now I'm ready to do my side hustle, calculate my molar mass. So I know for hydrogen gas, I have hydrogen, right? I know that there are 2 of them, and each one of them weighs, and I have to look at my periodic table. It's 1.01, but I come over here and it's 1.008. So each one of them weighs 1.0008. Okay, so that means my molar mass for hydrogen gas would be 2.016. And remember my units, grams per mole. Okay, Now check this out. The 2.016 goes with the grams. So that means in this case, it's going to be on the bottom. The 2.016 is now on the bottom because it's 2.016 grams per mole. The molar mass always stays, the number of the molar mass always stays with the grams. So last example problem, the grams was on top. Okay? Okay. The last step I do is I multiply everything on the top. 45 times 1 is 45, divided by 2.016 is equal to 22.32 moles of H2. Okay, cool. Now let's go ahead and do a couple example problems together in our interactive notebook. For this first one, we're talking about water, and we already calculated that the molar mass of water is 18.06 grams per mole. Is that correct? So let's go ahead and do this. How many moles of water is 45.6? 45.6 grams of H2O is equal to blank moles of H2O. Okay, I'll make this nice and big for y'all. Cool. As always, start with what I have. I'm even just going to copy it and put it in here. And what I want, I'll put over here. This unit right here is going to go on the bottom. This unit right here is going to go on top. And now it's time for me to enter my molar mass. Well, we've already calculated the molar mass, and it's 18.016 grams. So 18.016 grams for every 1 mole. That means the last step that I need to do is multiply everything on top. So 45.6 times 1 is equal to 45.6. And then I use the calculator. Oops. I use calculator, which I thought I had open. And I do 45.6 divided by 18.016. Bam. My final answer is 2.53 moles of water. So in the second one, we have 3.4 moles of CO2, and we're asking what would the mass of it be? 3.4 moles CO2. And we're saying, hey, what would it be, the blank amount of grams of CO2? Cool? Cool. What I'm going to start with is I'm going to do my side hustle first. I'm going to calculate the molar mass of carbon dioxide because I know I'm going to need it. So I'm going to say, hey, there's some carbon, there's some oxygen. Well, there's only 1 carbon and 2 oxygens. Carbon, I look over here, weighs 12.01. Oxygen weighs 15.999. 1 times 12.011 is 12 of this. Multiply these together, you get 3.998. Add these bad boys together, and you get 43 point, oh, I don't know, 009. Okay. Now, in terms of sig figs, use as many decimals as you can for right now, and at the very end, that's when you do the rounding. Okay. So that is 43.009 grams per mole. Okay, so now we're ready to do the conversion. I start with 3.4 moles of CO2. I want to know how many grams of CO2 it is. So I need to do a conversion that has moles on the bottom and grams on top. And I just did my side hustle, and I found that it's 43.009 grams of CO2 for every 1 mole. Notice, grams are on top here while they're on the bottom here. So that means the only thing I need to do is multiply 3.4 times 43.009. So I get 3.4 times 43.009, and I get 146.2306 grams of CO2. Now is the time to do sig figs. So it actually ran to 150. I wish I put a 0 here just so I can make this 146. Okay? Okay. I just was notified that this is actually calculated incorrectly. When you add these two together, it's actually 44.009. And when you multiply that, 44.009 times 3.4, then it's equal to 149.63. So we'll call it 150.